The second thing that we work on after right triangle trig. So right triangle trig, you can use Pythagorean theorem for SOHCAHTOA stuff. Then last week we worked on the law of sines, and now we introduced law of cosines, which is just another formula, but it can be used for any triangle. So in a situation like this, you have two hot air balloons approaching a landing field. So let's say they're trying to hit this spot. One is 12 meters from the landing point, and the other is 17. And the angle between the two balloons is 70 degrees. They would want you to find the distance between the two hot air balloons. So in this situation, if you're looking at it, I don't know if this is a right triangle or not. It's possible that it is, but we're not sure yet, right? So I can't do SOHCAHTOAs. And then when you look at the information, I do not know the angle that 17 partners with. I don't know the angle that 12 partners with, and I'm looking for the side that 70 partners with. So I don't have any information as far as using law of sines. So, on here it says the law of cosines for sides and law of cosines for angles. There's really only one law of cosines. And so let's just write it this way. X squared equals so that you're not confused, I'm going to put you can use variables if you want, but side squared plus side squared minus 2 times the side again times the side again times the cosine of some angle. And I'm going to do a dotted line. The side that I'm looking for so you're looking for that side, we're going to call it X. It's what we call its partner angle. The angle opposite that side is what is in the formula. So right now, when you use the law of cosines for sides, you have to know two sides of the triangle, right? So you have to know those two sides. So they appear as squared once in the formula, and then you use them again just as their number. So if I go back up to that triangle that we just did, the formula would look like x squared equals 17 squared plus 12 squared minus 2 times 12 times 17 cosine of 70. So it's the two sides that you know are squared. So it kind of has the Pythagorean theorem look to it, right? A squared plus b squared equals c squared kind of look. Then there's this minus 2 times the two sides. When I go to type it into the calculator, I just do the square root right away. So you can get the answer, then square root, I just put it in right away. And we had 12 squared plus 17 squared minus 2 times 12 times 17 cosine of 70 degrees. I guess you can close that here. But they're about 17, I assume this is miles, about 17 miles apart.
Wait, what is your scribble?
Um,
Oh.
Because it's x squared, yeah, so you can either get the number then square root, or I just do it right away. All right, so then they say the law of cosines for angles. I will show you the exact same thing. I'm going to write down 17.13 so we're a little more exact. 17.13. All right. So now I'm going to use the law of cosines to find the angle in the problem. And now I'm going to pretend that I don't know this side, and this side will be 17.13. So what it's going to look like is the angle and pair that go together, or the angle and side that pair up, will be those two. So I'm going to put the 17.13 squared first. Then I'll do my 12 squared plus 17 squared minus 2 times 12 times 17 cosine. I'm just going to call it A for angle. Cosine some angle. So what should we get? We already know what the answer is going to be. What am I going to get for that angle? 70 degrees, right? So we're just practicing what's it going to look like. So what do you have to do to get that A by itself? I would have to start by taking the 12 squared and the 17 squared and bring them over, right? So how do you get them to come to this side? All I want to do is move the terms from one side to the other. What do you have to do? What? Subtract them. So we're going to have the 17.13 squared minus 12 squared minus 17 squared. So that's all gone. It's to the other side now. So now we just have this negative 2 times 12 times 17 cosine of A. How do I get rid of the negative 2, the 12, and the 17? What are we doing currently with the negative 2, the 12, and the 17? We're multiplying. So how do I get rid of them? Divide. So now we're going to divide by the negative 2, the 12, and the 17. So negative 2, the 12, and the 17. So I'll bring it over here so you can see it. How do I get A by itself?
Cosine inverse.
Get rid of that cosine by doing the cosine inverse on both sides. So, on your calculator, you go to this original one, this one that I wrote in red, and all you have to do is type in what we just did. So we had 17.13 was being squared. I brought the 12 over, so I subtracted that over, and then I subtracted the 17. Right? Let's go ahead and hit enter. So those are those numbers squared, kind of the Pythagorean theorem looking numbers, bring them over. Then we divided by, and I'm going to put that in parentheses because there are three things there. We divided by the negative 2 times the 12 times the 17. That's what's on the bottom. So I'm going to hit enter again, and you should end up with a decimal, so that when you hit second cosine of your answer, the 69.997 would round up to, right? I mean, that's just 100th under, 3/1000ths under 70. So we didn't put in exactly the right answer. We used 17.13, but you can see how it's working. I will, yep. Now, what you've seen is when I've gone to the calculator, I have two things we have to do, but it's one formula, right? The same formula can be used to find a side. Basically, you just type everything in and then hit the square root. When you go to solve an angle, you have to do a little bit more work. You know, you got to move things around, and but it's the same thing. So when should you use the law of cosines? You should definitely use the law of cosines. And I'm putting blue dots down where you know the information. In other words, what's SSS again from geometry?
Side, side.
It's the side, side, side. If you know all three sides of a triangle, I would use law of cosines. Anytime you're using the law of cosines to find an angle, like in this situation, if you know all three sides, find the largest angle first. Because then, what we talked about the other day with the ambiguous case, if there's an obtuse angle, your law of cosines can find an obtuse angle. How many obtuse angles can there be in a triangle?
One.
Only one. So if you pull out the largest angle first, you avoid the ambiguous case. So if you know all three sides, once you find one of the angles, then you have choice. You can use law of sines or the law of cosines, whichever one you're most comfortable with. The other situation to use it with would be when you have what we call side angle side. If you have the side angle side, that means you have the two sides and the included angle. You know the two sides, and you know the angle where those two sides come together. Then you will be able to find the third side of the triangle. So you can use law of cosines to find an angle or a side. So if I was going to look at example number 1, if I'm going to find x because I have side angle side, we're going to go x squared equals 11 squared plus 18 squared minus 2 times 11 times 18 cosine of 56. I like using law of cosines because there's really nothing, I don't have to do any solving like we did with the law of sines. You gotta get x by itself, it's a little bit harder. Here, you can just do that. Some of you might even get into a habit of just putting the square root over all of it right away. But you should always look at when you're doing this triangle, if I do, what were the sides again? 11 and what?
18.
So 11 squared plus 18 squared minus 2 times 11 times 18 cosine of 56, right?
Yep.
I get a lot of students that give me that as their answer. Doesn't always make sense. I get it, some of these numbers. But can 223 be part of that triangle? Does that even make sense, that 223 would be? No. Can 56 be the largest angle of this triangle? No. 56, the only way it can be the largest if the next two are 55 or less, right? So 55 plus 55 is 110, plus 56 is 166. We're not to 180 yet. So there's no way this can be the largest angle. So there's no way 223 can be the largest side, this kind of deal. So always make sure when you're doing this problem that you remember to do the square root. 14.95 makes much more sense, right? So number 2, it says find the missing angle. So they're marking angle A. What angle should you find in this triangle?
Largest.
What's that?
The largest angle.
We should find angle B. How do I know angle B is the largest?
Because it's opposite the biggest side.
It's opposite the 13, which is the largest side. So I'm going to find angle B to make sure that when I find angle A, we're all right. So to find angle B, 13 squared minus 11, oh, a little too fast. 13 squared equals 11 squared plus 4 squared minus 2 times 11 times 4 times cosine of, let's call it angle B. When you are doing the law of cosines, I know a lot of you, you're going right to the calculator. But you need to write down your formula so I know what side you're using and where you're putting things. Once you've done that, if you want to show me how you're getting things by itself, that's great. If you type in the answer, that's fine by me. So, my 13 squared, I have to bring the 11 and the 4 to the left. So you have to go minus 11 squared minus 4 squared. Hit enter. Now you have the negative 2, the 11, and the 4 that you have to divide by. So we're going to divide that answer, parentheses, negative 2 times 4 times 11. And there's your decimal. Now hit second cosine, second answer. And this one is an obtuse angle. So sometimes if you don't pull that obtuse angle out of there, you can run into some major issues if you do law of cosine. So 111.32. Oh. So 111.32 degrees. With somebody sitting near you now, I want you to find angle A, and then we'll put the answer up there in a second. Now if I'm finding angle A, 11 is the partner, so that's what goes first. And A is approximately what? 52 point. So then to find angle C, you can do 180 minus those two added up, right? And then you've solved that particular triangle. Let's do it one more time. Find the largest angle on your own before you compare with somebody. Don't get any help. Find the largest angle in number 3. what is that approximate angle? You,
86.52.
what?
86.52.
86.52, anybody else get that? 83, 83.62?
Oh, I see what I put 6.3 instead of, wait, no, it's 6 point, or 5.2 instead of 5.
Okay, so 83.62 degrees. I'm gonna stop the video there. We're gonna do the next problem as an in-class assignment. If you need to check those answers, you can certainly go into Moodle and find the answers to the last problem.